I can also use the integration by parts formula in more creative ways. There's a lot of flexibility that the formula gives me. Once again, the integral of u times dv is equal to u times v minus the integral of v du. I'm going to use this formula to calculate an antiderivative for a function that I might not have seen the antiderivative before. Let's calculate the antiderivative of the natural log of x times dx. Now, wait a minute. I'm supposed to have the product of two different functions here. So what I'm going to do, right, all I have here is this log of x dx. I'm going to use one of the oldest tricks in the book. You are always allowed to multiply by 1. So this integral, I will say, is the integral of the natural log of x times 1 dx. Cool. So I have a product of two different functions. The derivatives of these functions do not allow me to use the u substitution. Derivative here is 1 divided by x. Derivative by here is 0. And I'm going to be forced to use integration by parts. Now, the whole reason I set up this integral is because I don't know the antiderivative for the natural log of x. I can't put natural log of x here because I don't know the antiderivative. So I will say that the natural log of x is what I will call u. That forces me to choose 1 times dx for my dv. Now, once I make that decision, the rest of this table sort of fills itself out. I need to have the derivative of my natural log function, right? That governs the exchange rate between my dx's and my du's. I need to find the antiderivative of 1. So that will need to be x is my antiderivative of 1. Now I can use my formula. I've got all my ingredients. I'm just going to put them in where they belong. This tells me that the antiderivative of the natural log of x dx, or the indefinite integral of the natural log of x dx, is going to be equal to u times v. Well, u times v is natural log and x. I like to put my x's out in the front. That's just a preference thing. I then have to subtract off the integral of v du. Well, that's x times 1 divided by x. So x on x dx. Well, this is just a funny way to write the number 1. Outside of the integral, I'm just taking this formula along for the ride. Inside of the integral, I can simplify and say that this is the integral of 1 dx. So what is my antiderivative for the function which is constantly equal to 1? My antiderivative is x plus my constant of integration. And I can distribute through with the usual hand waving that minus a number I need to solve for is still a number I need to solve for. Now, I know the antiderivative for the natural log function. The antiderivative is x log x minus x plus some constant.